Hey everyone, it's Adam Smith from the field engineering team at Matillion, taking you through a quick video on how to install the AWS EKS hybrid runner for Maia. Firstly, log into your Maia account. On the left hand side, there is lots of different tiles. This one here enables you to open up the runners and instances. Click on runners, click add runner. We're going to be installing a Maia runner today. We're going to give it a name, pick the cloud provider, picking AWS. We're going to go for an EKS deployment. You can pick either the current or stable track. The current updates once or twice a week. The stable is once a month. Both are fully tested. I'm going to go for the current to get the latest updates. Click runner, create runner. Here you'll be taken to this screen which will give you the status of the runner. It's usually set to pending when the hybrid runner or container has not connected to Maia. To deploy this runner, we go to the deployment tab. Here you've got two options here. You can either view the Kubernetes documentation or you can go to the public GitHub repository. We're going to use the public GitHub repository to install the Terraform templates and the Helm configuration. The installation is made up of two different parts. First, you have to install the infrastructure, which in this case is the EKS Kubernetes cluster. Then you have to install the Helm configuration. This allows your pods within your Kubernetes cluster to connect to your Maia account. Firstly, we have to download the deployment library. If we go over to this drop down here, we can select either HTTPS, SSH, or GitHub CLI. I've installed the GitHub CLI in advance of this video. I'm also using a Mac, but you can also use a Windows environment as long as it's got access to an SSH or Bash terminal. This is my Bash terminal here, so I'm just going to simply copy the GitHub CLI, paste the command. It's now going to download the deployment library, and I'm going to use Visual Studio Code to assist me with the deployment today, but you can use any editing tool which you're familiar with. I'm just going to open up Visual Studio now, navigate to the folder I've just downloaded, the deployment library folder, and within Visual Studio Code we have the option to use a terminal. If we go back over to the repository here, the deployment library repository, it has a very useful README which gives you full instructions on how to install and set up your Kubernetes cluster as well as the Helm chart configuration. The first option you can use if you've already got a Kubernetes cluster already configured, but in our case we need to deploy the EKS infrastructure using Terraform. So we need to go to section 3. So I'm just going to scroll down here. It already tells us about certain prerequisites and installations we need to do in advance. I've already installed Terraform and the kubectl CLIs as well as the AWS CLI. It also mentions I need access to AWS EKS or permissions to create EKS clusters. And when it refers about AWS CLI with the appropriate permissions, I will need the AWS CLI to have access to my AWS account. So I've configured my AWS CLI to have access to AWS. Now I'm going to go back to the README instructions and scroll down to the AWS EKS deployment section. There's lots of useful information here, but the main section really just gives me everything I need. So we've already cloned the deployment library and we're in the deployment library folder. Now I'm just going to simply copy these instructions. So back over to Visual Studio Code. We are now in the runner AWS EKS folder. I'm going to copy the Terraform TFVARs example. And then here it says you need to edit the Terraform TFVARs with your AWS values. So we're going to go over to the runner folder, AWS. We're doing an EKS deployment today. And now I'm going to open up the Terraform TFRs file which we've just created from this example. We've got a few different options here, and you can use an existing VPC or existing subnets if you want to. For this example, I'm just going to keep the default. So we're going to get the Terraform to create a new VPC and appropriate subnets. We've also got options for existing subnets IDs, but we're going to get the Terraform to create the subnets for us. I'm going to keep the default CIDR block. In my case, I'm going to pick a different region. I'm going to keep the name, but you can change it if you require to. It's also got some default tags which it adds, which you can add additional ones or change these if you wish. Just to aid my configuration today, I'm going to set the private cluster as false, but you can set it to true if you were setting up this in a production environment. There are some other examples here which we've given you in advance. And that's it. So you don't really need to change anything in this Terraform template. So if I go back to the instructions over here, now all we have to do is initialize the Terraform and deploy it. So firstly, I'm going to go back to Visual Studio Code, run the Terraform init command. Now I'm going to get Terraform to create a plan. This hasn't resulted in any errors, so now I'm going to run a Terraform apply. The deployment typically takes between 5 to 10 minutes. We just need to confirm it and type yes. So I'm going to just let it go through and create all the different services and resources it needs to create. I'm going to fast forward to the end of this creation just to speed up the video. Once the deployment is finished, you should get a similar sort of output to this. Some important parts, it's useful for you to copy this command down just so that this will configure which Kubernetes cluster you are applying the Helm configuration to shortly. So I've just copied this and I'm just going to run this. I'm also just going to copy down the rest of this just in case I need it later on. Within your AWS account, you should now have a new EKS cluster configured and active. Once this is installed, you are now ready to go on to the next step, which is installing the Helm configuration. So this configures the pods in your EKS cluster to connect to Maia. If we go back over to our deployment library README file, we can now scroll up to the top to the Kubernetes deployment section. We've already cloned the repo previously, so we need to run these commands first. So these are to create the Matillion and Prometheus namespaces. Back to the README. For this, we need to make sure we are in the root of the deployment library folder. So I'm just going to navigate to the main deployment library folder on my terminal. We're going to install the Prometheus monitoring. You can go through this now and run things just to check the status of the Prometheus pods. I'm just going to move on to the next section. We're doing an AWS EKS deployment, so this is the examples YAML file we need to copy. We see on the left-hand side we've now created a my-files YAML file. You'll notice this will be slightly different from if you've done an Azure or GCP deployment. We've got example files for all the different types of deployments you can do with a hybrid runner. There's an overview of the different runner sizes. There is also documentation on the docs.maia.ai documentation site. We're just going to go for the small runner size today. And there's some different options which we will need to configure. Firstly, we need to configure the OAuth client ID and client secret credentials. So we'll go back over to our runner, click the credentials tab, reveal the credentials. These are not a one-time only display, so you can come back to this later as well. We'll get the client secret. We do now need to set the service account role ARN, which we copied earlier. Scrolling down now, we also need to set the other values. So we need the account ID, the agent ID, and the Matillion region. So the account ID, the agent ID, and it will say what the Matillion region is within your runner configuration within Maia. EU1 for me, but it might be US1 for you. So we're just keeping that the same. And then there's some additional options you can set, such as proxy configuration, custom certificate locations, extension library locations, and also external driver locations. For the custom cert locations, extension library locations, and external driver locations, this will require you to point to a S3 bucket location. Let's scroll down and see if there are any other options which we need to set. So once you've configured those different options, we now need to deploy the Helm configuration. If we go back to the README file, we have this useful command here which enables us to install the runner. If you do need to change these options later, you can change the command from Helm install to Helm upgrade. Now we've installed the Helm runner, we can check if the pods are running, and we can see here that they've got the status of pending because they're still being deployed. So I'm just going to give it a couple of minutes now and fast forward to when the runners have been created. We can now see that the containers are being created. We've got this configured to deploy 2 pods. So we've got 2 pods being created here, and it's just downloading the image from this repository location. Now that our containers are running, we can go back over to our Maia runner. If we click overview here, it's still got the old status of pending. So we just need to refresh the tab. And this means that our pods have successfully connected to Maia, and we're now ready to continue with the setup of the Maia projects and your environments connecting to your different data cloud providers. If you need any more assistance with this, feel free to go to the Matillion documentation site. Also, the Matillion support portal has lots of really great, useful information on here, as well as knowledge base articles, links to our documentation as well. You can also send questions to our agentic AI support agent, as well as logging in and creating support tickets if you need any additional further help. Hope you enjoyed the video. Thanks for your time.